guys, isosceles and equilateral triangles. First, we need to talk about the three types of triangles before we can actually do problems with these. So we're going to start off with what's called a scalene triangle. They are the most obvious because they have none of their sides the same. So 3 different side lengths is going to be the key on this. 3 different side lengths. Okay, with these 3 different side lengths, you're also getting 3 different angles. And you can tell by the marks on there, you've got 1 mark here. Notice it marks up with the 1 mark across from it because they are connected to each other. This side, then we've got 2 here. It matches up with the 2 in this angle over here. It should. No, that's 3. Sorry, I was reading backwards. 3 over here that matches up with the 3 on this side. We've got 2 right here that matches up with the 2 over here. But all 3 are different on the angles and all 3 are different on the sides. That's called a scalene triangle. There is nothing special about a scalene triangle. Those are going to be the ones that don't really give you anything unique. You won't see any problems really based on a scalene triangle other than the total inside. Guys, what's the total inside every triangle? Ooh, guys, what do the angles always add up to? 180. No matter what, you know that it adds up to 180. That's the biggest thing you'll see on scalene triangles is they'll deal with the angles adding up to 180. Now, isosceles is going to be the most special as far as the ones that have the most problems. They love to do isosceles triangles in the EOC. These are going to be something you see a lot. So let's start off with the vertex angle. I'll get it. Just let me get this up here real quick. This is the vertex angle. And this is going to be the base angles. I'll explain them in a second. Let me get the door. Y'all get that written down. And we'll go over what that actually is. So in an isosceles triangle, you've got... Please wait for a minute. I'm talking. I know that, but I'm talking. Please don't talk when I'm talking. Okay. So, in an isosceles triangle, there is a vertex angle. That vertex angle is going to be between the 2 congruent sides. That vertex angle is going to be different than the other 2 angles. So that vertex angle is going to be unique. And then you've got 2 base angles that are going to be congruent to each other. Those base angles are always going to be across from the congruent sides. Okay? So those base angles are always going to be across from the congruent sides, and they're always going to be equal to each other. They are always going to be congruent to each other. Right? Now, the unique thing about this, it's very odd, is that the definition says it has at least 2 sides congruent. Now that, not congruent, the S is on the wrong word, congruent. 2 sides congruent. This is very tricky because when you categorize isosceles triangles, a lot of people miss this because if you have an equilateral triangle, it also has at least 2 sides congruent. So if something is equilateral where they're all the same, it is also going to be isosceles because at least 2 of them are going to be the same. So if you ever mark something as an equilateral triangle, you are also going to mark it as an isosceles triangle because they're going to get you to categorize them. So from here, that doesn't mean the other way around. Just because it's isosceles doesn't mean it's equilateral. Okay? So the other thing is the base angles are congruent. Base angles are congruent. Base angles are congruent. That's the other piece that you got to get out of that. Base angles are congruent. Okay, now equilateral is exactly what it sounds like. In an equilateral triangle, you're going to have 3 congruent sides. You can see that all 3 sides are marked the same. And they all have 1 mark on them, so it's going to be 3 congruent sides. But if it has 3 congruent sides, then it also has 3 congruent angles. Okay. Now, the thing about an equilateral triangle is that the angles are always the same because they're always taking that 180 that you start with every single time inside of a triangle and dividing it evenly 3 times. That means the angles inside of an equilateral triangle are always going to equal 60 degrees every single time. Like, you should not have to figure that out. Every single time, the angles inside of an equilateral triangle are always going to be 60 degrees each. every time. Just set them equal to 60. Okay. Now, I'm going to put up here this little note. Okay. This is also an isosceles triangle. ISOS. The easiest way to remember this word is SOS. Remember that SOS. CELES. A lot of people do not know how to spell isosceles. ISOS, CELES. So isosceles triangle. An equilateral is always going to be called an isosceles as well. That's something really important to make sure you know, because the first thing we have to do is problems like examples 1 through 4, and people are going to miss this first one for that exact reason. So the first problems you're going to see on your homework tonight are going to look like, excuse me for 1 second. Sorry guys, my son is sick. I'm scared I'm getting it. Okay guys, so your first, oh wait, anybody still writing? No? Okay. Your first ones are going to look like this. You have to go through and click all that apply to each triangle. And so this one has all 3 sides the same. If all 3 sides are the same, that makes this an equilateral. But because it's an equilateral, what else do I have to do? Yeah, check isosceles. If it is equilateral, you must also click the isosceles button. If you don't, even though you mark equilateral, it is going to mark it wrong. It's not going to let you get credit for this problem. On this one, we've got a 30, 60, 90 triangle. If you do not know, that is a very special triangle. There is a lot we are going to learn about this triangle in second semester. The sides are related in special ways. Right now, all we need to know is that all 3 angles are different, which means all 3 sides are also different, which means this is a scalene triangle. On the next one, all 3 sides are different. You don't even have to look at the angles. If all 3 sides are different, this is also going to be a scalene triangle. Now, the next one requires a little thought. It's a little backwards. It goes from the angles instead of the sides. You can see right here you have 2 angles that are congruent to each other. This is also a very special triangle. It's called a 45, 45, 90. The sides are connected with the hypotenuse. You have a very special relationship that we're going to learn in second semester. But for now, the biggest thing you need to know, 2 angles are the same. That means the sides across from it are also going to be the same. And if they're the same, what kind of triangle does that make it? Yeah, isosceles. Perfect. There you go. Any questions about classifying them before we go on to doing the ones where we're finding the missing angle? Yeah. Which one? Okay, there's 2 angles the same, that makes 2 sides the same, and anytime you have 2 sides the same, it's going to be isosceles. The easiest way that I learned it was, if it's SOS, there are 2 sides that are going to be congruent. 2 S's right there together. Hey, look, I look for any connection in my mind. I was always looking for a cheat, something that made it stick. Anybody else? Okay, here we go. So for the next one, this is about finding angles and missing angles in the picture. So we're looking for F right here, but we can see that we have 2 sides the same here. And guys, the marks on the picture are everything. Please use the marks on the picture. If these 2 sides are marked congruent, then these 2 angles also have to be congruent, which means we're going to take the 180 degrees that a triangle adds up to. We're going to subtract this vertex angle right here, which is 110 degrees. That's going to leave us 70 degrees. And then I need to split that evenly between the 2 base angles that are congruent to each other in this isosceles triangle. To do that, we're going to divide both sides by 2. And each one of those angles is going to be how much? 35 each, which means your answer to the problem is 35 degrees right there. I'll put it above it. You can't really kind of blur it out by the box. 35 degrees right there. Okay, on the next one, you can see that all 3 angles are the same. They're not looking for the angles this time. You already see all 3 angles are 60 degrees. But if all 3 angles are the same, then all 3 sides are also going to be the same. Which means how long is every side? 3. It's right here, guys. If this side is 3, then this side's also got to be 3, which means this side's also got to be 3, which means AD is going to be 3. Okay. Again, one more time. 2 angles the same in isosceles, 3 in equilateral. 2 sides the same in isosceles, 3 in equilateral. Questions? Okay, here we go. Next type, these are a little more connected to each other. You have to use some old stuff mixed with new, lines adding up to 180, that kind of thing. Okay, here we go. So we have this triangle where we know this angle is 75 and it is a base angle inside of an isosceles triangle where this side is congruent to this side. That means this base angle is going to be congruent to this base angle. So if this one is 75, this one is also going to be 75. Okay. Once you know two angles inside of a triangle, you should be able to find the third by now. That's old stuff. Add 75 plus 75 and get that total. What's that, guys? Y'all are the ones with calculators. It's 150. And then from there, we're always subtracting from 180 in a triangle. So 180 minus that 150 is going to leave you a vertex angle of 30. Okay, we're using that triangle to get to this new triangle to find this missing angle. I know that this angle is a right angle down here in this corner. Okay, if this is a right angle in this corner, it's worth 90 degrees, and I've already used up 30 of it here. I need to find out what's left over to go in this spot. So I would do 90 minus 30. Guys, do not get on your phones while I'm teaching. Don't make me have you turn your phones in. That's going to put you at 60. So that 60 is going to go right here. Now, 60 is the vertex angle inside of an isosceles triangle. I'll switch colors so you can see it really clearly on the marking. Isosceles triangle, where these two sides are congruent to each other. That means these two angles at the bottom are both going to be congruent. Those are going to be base angles. So we're going to do the same thing again, guys. It's the same process over and over and over again. 180 minus that vertex angle of 60 is going to leave me 120. Then because the base angles are congruent, what am I going to do to the 120? Yeah. And each one of those angles is going to be 60. Oh, not only is it isosceles, it is also what? Equilateral. It is equilateral because all three angles are going to be the same. But what's the answer to the question? It is 60 degrees. We're only worried about that one angle, guys. It's the only angle we care about. I can tell you I've seen problems like that on the EOC repeatedly. They love the ones where they're connected to each other and you have to do more than one thing. We have to do an equilateral with an isosceles because then they get to count that for both things for what they're covering. So you can probably expect to see some like that. Yeah. I feel that.
Do we have to tell you when trying to look at the
I don't know what you're asking me.
like how that
Don't understand what you're asking me, so I'm trying to figure it out. Okay, watch the next one. Let me know if you. I just don't think I'm understanding what you're asking. So let me know on the next one. I think the answer is no, but I want to be careful because I don't know what you're asking. I think the answer is no. So if this angle right here is 29, it's in an isosceles triangle where two sides are the same. That means those base angles are the same. So if this side's 29, this side's also got to be 29, which means we're going to add 29 plus 29. 18, carry your 1, be 58. Then we take 180 and subtract that 58. Do that math. Tell me what you get. 122. So 122 is going to go here for our vertex angle. Is that what you're talking about? Does the vertex have to be the same as the others? Okay. Huh? Not yet? Okay. Getting there. So the next one is going to be, we got to get to this triangle, but we don't have a right angle this time. We have a straight line, and every straight line adds up to 180. So we basically go backwards. Guys, you don't have to do this, but look at the math. It's just, do y'all understand this is just backwards from what I did right here? This is the same thing as this, just backwards. So if I'm doing 180 minus 58, I got 122. So if I do 180 minus 122, what am I going to get? 58. 58. So now I'll switch colors back again. If this base angle in this isosceles triangle, here's the two sides that are the same. That means these two angles have to be the same. So if this base angle is 58, then this base angle is also going to be 58. And then to find x, all you do is 58 plus 58 equals 16, carrier 1, that'd be 11, 116. And then 180 minus 116, because every triangle adds up to 180. You're just subtracting from 180 every time, guys, at the end. Once you get those added up, it's going to give you the 6. Oh, yeah, you bar. Sorry, 64. Perfect. And x is going to be 64. That's the actual answer to the question, 64 degrees. Okay. Questions? Anything on 7 or 8? These are very common on the test as well as the reviews. This is going to be something you have to be able to do. Now, I think the last one's probably the easiest one because it's algebra based and y'all do well on these types of problems and all the stuff you've done so far. You just got to know what to do, add them up to 180 or set them equal to each other. In this case, we're going to set them equal because they're going to be base angles. So let's show you what we mean because every problem is going to be different. You do have to read the question and see what it's saying. So it says you got an isosceles triangle. Here's the isosceles triangle where the two sides are the same. That means these base angles across from it are going to be congruent to each other, which means we're going to set this equal to this. So set up your equation. 4x plus 31 is going to equal 2x plus 41. So from there, we're going to solve that. Minus 2x minus 2x. It's going to put us at 2x plus 31 equals 41. We're going to minus 31. The numbers actually work out pretty nice in this one. Minus 31, that's going to be 2x equals 41 minus 31 is going to be 10. Divide by 2, and x is going to equal 5. Now, it does not, it does not ask for x. It asks you for the measure of the angles. How are you going to get the measure of the angles? I got to plug it back in. We'll plug it back in. We only need to plug it in one. It doesn't matter which one you plug it into. You're going to get the same answer. So just grab your calculator and type 4 times 5 plus 31. I'll let y'all do that. 51. So that's going to be h is 51 degrees. If h is 51 degrees, then I is also going to be 51 degrees. And then for the last one, we're going to go through, and guys, if you know two angles in a triangle, you can find the third by adding and subtracting from 180. So we're going to add 51 plus 51. That's, I put the plus and the 1 in the wrong places. 51. That's going to get, bless you, 102. And 180 minus that 102 is going to put us at 78. That's going to be our vertex angle, is 78 degrees. Okay, guys, that's your notes for today. Anybody have any questions before we move on? Did I ever answer your question? Okay, come ask me. Okay, guys, put that in your folders. Let's go ahead and get you moved on to your assignment. I'm going to leave this up here in case you're still writing, but you can go ahead and get moved on to Alex. I'll get my GoGuardian going. When y'all are ready to get on there and get going on that assignment. Hey, what you got?
You got 60.
I got what?
Yeah, 60.
I didn't get 60 anywhere in that triangle.
So
Yes. So I did this triangle, added 75 plus 75 and got 150.
okay.
And then I did 180 minus 150 and got 30. That's the angle right there, 30. And then I did, because this is a right angle, how big are right angles? I did 90 minus that 30 that I already did, and that left me 60 for the other side. It's like part plus a part equals a whole. 60 plus 30 equals.
I think I asked the question.
Okay.
I'm trying to see, do we go based off the angles in that first triangle?
They're going to be completely different from the second triangle. But we need to use the first triangle to get a measurement in the second triangle.
Okay, that's it.
Yeah, they're not the same, but you will use the first one to get a second. Is that better?
Yeah.
Okay. Thanks for helping. I just didn't understand what the question was. Okay, guys, get on there. Let's see. Y'all in there. You should have plenty of time to get a lot of this done. We don't get out till 8:30 in this class, so you've got lots of time to work on this. Ask questions, please. Okay, Adriana's still not here. Zoe's still not here. No, isn't here. No. Okay. Let me exclude them from the session. Adriana. Gavin, let's go, son. Come on. Get on there. You need to get into Alex. Zoe. Maya. Are you still finishing it? You're good. Oh. Huh? Okay, why? Oh, you're going. Okay. Just make sure you get that done tonight, okay, son? Bella. Bella, what's going on with yours? You're doing it, okay, okay, you're good. Just make sure it gets done tonight. I'm sorry y'all have to do homework tonight, though. That's frustrating. Do y'all have your phones? You can do it on there. You can access it. No. If you don't, it's fine. It's a way to get it done. Yeah. Yeah, absolutely. Thank you for letting me know, sir. Thanks. Awesome. Brian's getting in there. Chris, oh, you're getting logged in. Gavin's getting logged in. This one. Okay, good. As long as I can see you working in there, you're fine. Thank you for letting me know, though, and I'm not going to give you a 0 for it. Guys, you just got to communicate. Communicate. We just finished up notes, so I can go through the scene. I don't worry that it's getting something. I'll go through the slides and just tell me when you're ready to move to the next slide. If you have a question, let me know, okay? Because I don't have a video for it yet to post.